Apple's phone chip got so powerful, it replaced their laptop processor. Here is how that happened. Starting from the chip they didn't even design, Samsung ARM. The original iPhone ran on a Samsung processor, not Apple's chip, not a chip Apple designed. A Samsung ARM 11 running at 412 MHz on a 90 nanometer process, the same foundry Apple would later spend years trying to escape. Apple wrote the software. Apple designed the hardware body. Someone else built what was inside. Steve Jobs had famously rejected Intel for the iPhone because Intel was too slow to move, and Apple didn't want to cede that much control. The irony is that for the first 3 years of the iPhone, Apple had no control over the processor at all. Samsung built it. Samsung manufactured it. Apple depended entirely on a competitor. That arrangement had an expiry date from the moment Jobs allowed it. Apple A4. In 2008, Apple acquired a small semiconductor company called PA Semi for $278 million. Then they acquired Intrinsity, combined the teams, gave them a target. 2 years later, they shipped the A4, the first chip Apple had designed themselves. One core, Samsung's 45 nanometer process, but the architecture, the clock targets, the design decisions, Apple's. The lead architect was Jim Keller, the same engineer who later designed AMD's Ryzen, the series that eventually forced Intel to compete again. Apple had him first. The A4 was designed not as a general-purpose chip, but around a specific constraint. It had to drive the iPhone 4's Retina display without destroying battery life. Apple didn't design the screen and then find a chip. They designed the chip to make the screen possible. That sequence, hardware built around the software experience, not the other way around, became the template for everything that followed. Apple A5. The A5 doubled the CPU cores and multiplied GPU performance by roughly 9 times compared to the A4. Mobile gaming permanently changed with this chip, not because of a single title, but because the performance ceiling lifted far enough that developers stopped compromising. The A5 also made Siri possible. Apple launched Siri as an A5 exclusive feature, saying the A4 lacked the computational headroom. Hackers proved that wrong within weeks. Siri ran fine on the A4. Apple had locked it to the newer chip to drive upgrades. This is worth remembering every time Apple announces a feature tied to the latest hardware. The event where the A5 was announced, the iPhone 4S launch on October 4, 2011, was the last time Steve Jobs appeared on stage. He died the following day. The chip that came 2 years later is where the story starts to get uncomfortable for the rest of the industry. Apple A7. The A7 was the world's first 64-bit processor in a consumer smartphone. 1 billion transistors, an architecture Apple called Cyclone, a secure enclave, a hardware vault for Touch ID fingerprint data that even Apple's own software couldn't read directly. The industry reaction was immediate and revealing. Qualcomm's CEO publicly dismissed 64-bit mobile as a marketing gimmick. Internal emails later showed the reality. The A7 sent ripples of disbelief through Qualcomm's engineering teams. Nobody had seen it coming. Nobody had been close. Qualcomm scrapped their roadmap, abandoned their custom chip designs, and rushed to 64-bit using off-the-shelf ARM reference designs they hadn't modified significantly. The product that Panic produced was the Snapdragon 810, a chip that overheated so severely under load that it nearly destroyed Qualcomm's reputation for 2 consecutive years. Apple's 64-bit announcement didn't just beat the competition, it accidentally broke it. Apple A9. For the iPhone 6s, Apple couldn't get enough chips from a single manufacturer. They sourced the A9 simultaneously from 2 foundries, Samsung at 14 nanometer and TSMC at 16 nanometer. Same chip name, 2 completely different physical implementations, different die sizes, different fabrication processes, different power characteristics. Users worked it out. Ars Technica ran controlled tests. The TSMC version lasted around 2 hours longer under sustained CPU load. Roughly 22% better endurance. Apple's official position, real-world difference is 2 to 3%. Both were technically accurate for different use cases. This is the only moment in Apple history where customers could look up a serial number to determine which factory had built their phone. Many did. Some returned theirs. Apple offered no replacement program, no acknowledgement, no adjustment. They moved entirely to TSMC the following year and never mentioned it again. Apple A10 Fusion. The A10 Fusion introduced something structurally new, a 4-core layout with 2 high-performance Hurricane cores and 2 low-power Zephyr efficiency cores, drawing around 20% of the power of the main cores. This architecture, fast cores for demanding tasks, slow cores for background work, is now universal across every major smartphone chip. Apple invented none of the underlying concepts. ARM's Big Dot Little had existed for years, but Apple's implementation, integrated tightly with iOS power management, was the benchmark every competitor aimed at. Single-core performance on the A10 matched the 12-inch MacBook of the same year, a phone chip equaling a laptop chip. That comparison was already remarkable. What was not remarkable, because Apple didn't announce it, was what happened in January 2017. Apple quietly pushed iOS 10.2.1. Inside that update was code that reduced peak performance on iPhones with degraded batteries, including devices using the A8, A9, and A10 Fusion. Their reasoning: old batteries couldn't deliver the current these chips demanded at peak load, causing sudden shutdowns. Smoothing the power draw prevented those shutdowns. The reasoning was sound, the secrecy was not. A Reddit user named TechFire noticed his iPhone 6s ran faster after a battery replacement. Benchmark data from thousands of devices confirmed the pattern. Apple admitted it on December 20, 2017. The settlement cost between $310 million and $500 million. France fined Apple 25 million euros. Italy fined them a further 10 million euros. Apple dropped battery replacement prices to $29 through 2018 and added a battery health indicator to iOS. The technical decision was defensible. The decision not to tell anyone cost them years of headlines and $500 million. Apple A11 Bionic. The A11 introduced the Neural Engine, dedicated hardware built specifically for machine learning tasks. 2 Neural Engine cores, 0.6 trillion operations per second, built to process the 30,000 infrared dots Face ID needed to map in milliseconds. First in any smartphone, first in any consumer device. It also made a structural change to how the chip's cores operated. All 6 CPU cores, 3 performance, 3 efficiency, could now run simultaneously. The A10 forced a trade-off between the 2 clusters. The A11 eliminated that constraint. The AI hardware was impressive. The restriction Apple placed on it was notable. The Neural Engine was locked entirely to Apple's own apps at launch. Every third-party developer on the App Store locked out. All that dedicated AI processing, sitting unused by every application people actually ran. Apple opened access to developers the following year. Apple A12 Bionic. The A12 was the first 7nm chip shipped in any commercial product in the world. Not just in a phone, the first anywhere, across any category from any manufacturer. Qualcomm was still on 10nm. Intel was still on 14nm for most of its lineup. Apple was a full process node ahead of the entire semiconductor industry. 6.9 billion transistors. The Neural Engine jumped from 0.6 to 5 trillion operations per second. When the A12's Geekbench scores first appeared online, analysts assumed they were fabricated, mislabeled MacBook results posted by mistake. They were real iPhone scores. Single-core performance matched a 2017 iMac running a desktop Intel Core i5. A phone, benchmarking even with a desktop computer released the previous year. Apple quietly placed a variant of the A12, called the A12Z, inside the Mac Developer Transition Kit they sent to software developers the following year to prepare for Apple Silicon, a phone chip previewing the Mac's entire future. Apple A14 Bionic. The A14 was the first 5nm chip ever manufactured by any company for any product. 11.8 billion transistors, a 16-core neural engine, the largest performance leap over a predecessor since the A11. But the story of the A14 isn't what it was, it's what it became. Tech Insights performed forensic analysis on both the A14 and the M1 chip Apple unveiled 2 months later, the chip that replaced Intel across the entire MacBook lineup. Their finding: the CPU cores in the A14 are microarchitecturally identical to those in the M1. Same decode width, same execution units, same instruction set support. Apple wasn't just building a phone chip when they built the A14, they were building the MacBook. The phone came first. The laptop followed 2 months later using the exact same cores, doubled in count, with Thunderbolt and PCIe added around them. Every MacBook Pro that embarrassed Intel laptops costing twice as much ran on cores Apple had already shipped inside an iPhone. The M1's performance advantage over Intel wasn't a Mac breakthrough. It was an iPhone breakthrough that arrived in a Mac chassis. Apple A15 Bionic. Apple did something at the A15 launch they had never done before. Every previous chip launch compared the new chip to the previous year's chip. The A15 launch slide compared the chip to the competition. The lead over Android was large enough to make the comparison flattering. The lead over the A14 was close enough to be awkward to show. Apple also split the A15 across its product line in a way that hadn't been done before. The iPhone 13 Pro received a version with a 5-core GPU, while the standard iPhone 13 got a 4-core version. Same chip name, meaningfully different specifications, same price tier. Then a year later, Apple shipped the iPhone 14 with the A15 again. The same chip, unchanged, 1 year after the 13 Pro, at the new model's price. Most buyers had no idea. Benchmarks made it plain. Sales were unaffected. Apple A16 Bionic. Apple called the A16 a 4nm chip. The foundry designation tells a more specific story. TSMC's N4P process is a refined variant within the 5nm family, not a true architectural transition to 4nm. The label was directionally accurate. It was also marketing adjacent. What the A16 genuinely delivered: 16 billion transistors, a dedicated display engine, a low-power block that kept the always-on display alive at 1 Hz while the rest of the chip slept, and single-core performance 40% ahead of the Snapdragon 8 Gen 1. One detail Apple never mentioned publicly: hardware ray tracing was fully built into the A16's GPU silicon. Internal reports confirmed it was pulled from the launch because a power management flaw made it unusable. Apple held it, released it 1 year later as the A17 Pro's headline gaming feature. The world's first was real. The timing was managed. Apple A17 Pro. The A17 Pro was the first true 3nm chip ever shipped in any consumer product. Apple reportedly secured TSMC's entire first-year N3B production capacity. No other company could meaningfully access 3nm for a significant period after the iPhone 15 Pro launched. 19 billion transistors, hardware ray tracing shipping for the first time, the neural engine at 35 trillion operations per second, the threshold Apple later defined as the minimum requirement for Apple Intelligence. Console-quality games ran natively on a phone for the first time in any serious sense. Then it ran hot. The iPhone 15 Pro's titanium chassis conducts heat roughly 20 times less effectively than aluminum. The A17 Pro generated heat the body couldn't dissipate. Everyday apps triggered thermal throttling that titanium amplified. Apple never publicly acknowledged the chassis as the problem. The fix arrived with the next generation. Aluminum replaced titanium in the thermal path design. Apple A18 Pro. The A18 Pro was designed from the ground up around Apple Intelligence, Apple's on-device AI system. The base A18 chip, across every iPhone 16, shipped with 8 GB of RAM as standard for the first time. Not for general performance, because the large language models Apple Intelligence required to run locally needed 8 GB to load. The hardware was defined by the software requirement, and for the first time in roughly a decade, Qualcomm won a meaningful benchmark. The Snapdragon 8 Elite shipped with fully custom CPU cores, Qualcomm's first in-house architecture since 2012, mirroring exactly the strategy Apple had run since the A6. In Geekbench 6 multi-core, the Snapdragon 8 Elite scored 9,188. The A18 Pro scored 8,744. Android crossed Apple on multi-core performance for the first time in years. Context matters. Android chips run 8 to 10 cores, Apple runs 6. Qualcomm matched multi-core totals by adding more cores, not by matching Apple Core 4-core. In single-core performance, the number that determines how fast your apps open, how responsive your UI feels, Apple still led. But the gap had closed, and Qualcomm had finally learned the lesson Apple had been teaching since 2012. Apple A19. The A19, shipped with the iPhone 17 line in September 2025, continued on TSMC's 3nm family at a refined N3P node, roughly 10% smaller than the A17 Pro's die. GPU performance increased by 33% over the A18, the largest single-generation GPU jump since the A11 Bionic. But the architecture decision underneath matters more than the number. Since the A11, the neural engine had been a separate block on the chip, a dedicated AI island sitting apart from the CPU and GPU. The A19 starts dismantling that boundary. Neural accelerators are now integrated directly into every GPU core. The GPU and the NPU are converging. AI processing is no longer a separate task assigned to a separate block. It is woven into the standard rendering pipeline. The chip that comes next will continue that convergence. The industry that spent years trying to match what Apple was doing in 2019 is now trying to match what Apple is doing now. The same chip architecture that powered these iPhones went into Apple's laptops and changed what a MacBook could do. Every MacBook generation explained is on screen right now.